Okay, so we're continuing our conversation with the state, but could we talk about that for a second? Why is there so much crappy software out there? The tab crashed. Like, I'm on the Spotify web app. Why is it just crashing? Which is why I need you all to test your code, so when you get out there, you can start releasing better code that doesn't break constantly. I'm so sick of using shitty software. It's everywhere. I had... since I'm already going on this tangent, I'm doing it again. Over the last weekend, I went to an ATM. I just need to get out some cash, put my card in the ATM like a regular human person. I punch in my PIN. I say, give me some money. A Windows dialog pops up that says, Windows is shutting down, and the whole machine restarts, and then it eats my card. It was one that actually takes your card inside the machine, eats my card, and now I have no card and no cash, and I'm just SOL for the rest of the day. I had to ask a whole bunch of people to borrow money. It was a mess because they have shitty software in an ATM. An ATM should be thoroughly tested. And then fighting with Spotify, man, there's just too much bad software out there. Please do better. Please be better. All right, so we're continuing our discussion about the state pattern. There's not going to be slides for the rest of the week. We're going to go in IntelliJ, do a whole bunch of live coding. So today I want to do exactly that. We're going to do live coding. I want to write a TV class that's following this spec sheet. So this is similar. This is meant to parallel your homework fairly closely. It's simple enough to fit in one lecture, but it's following the same kind of a structure as the calculator homework. So I have this spec sheet of all the features that I have to have, just like your calculator has to have certain sets of features. Same idea. And of course, we want to implement this without using any conditionals, which is going to force me to use the state pattern. So I want to go through this and talk about how to use the state pattern to set this up. So let's go through the specs first. We'll go through the specs a few times as we're designing the architecture of our program. But let's go through it one time just to figure out what we're even dealing with here. So we have a TV class that should be initially off. When I first plug in the TV, it should be off. It shouldn't turn on automatically, is the idea there. The initial volume is going to be 5. And when the TV is off, I'm going to have a volume up and volume down button, which should do, and a mute button, which all should do nothing. If the TV's off and you're trying to mess with the volume, it shouldn't do anything. Or else you have situations where somebody keeps hitting the volume up button when it's off, and then they turn it on and the volume's way too loud. You don't want that. Not a feature we want. And the current volume is going to be 0. So we're going to have this idea of current volume being the volume of the noise that's currently being made by the TV. So the initial volume is going to be 5, meaning that when you first turn on the TV, the volume will be 5. But when it's off, if we ask the TV for its volume, it should say 0. I'm not making any noise right now. There should be a power button, which is going to turn the TV on and off. We'll have a volume up button, which will increase the volume by 1 to a maximum of 10, and a volume down, which decreases the volume by 1 to a minimum of 0. We're going to have a mute button, which is going to mute and unmute the TV as long as it's on. If it's off, this button doesn't do anything, as mentioned up here. Somewhere up here. Right here. And when the TV is muted, the current volume is 0. It's not making any noise. But when it's unmuted, it should restore back to the volume that it was at before it was muted. So whatever volume level it was at should be retained when it's unmuted. And the mute, volume up, and volume down button will all do the same thing when the TV is muted. They should all unmute the TV, and that's it. This, just like the calculator, and anytime I design a homework or like a spec sheet like this, I just play around with the devices around my house. So that's what my TVs at my house do anyway. When the TV's muted, which I found out just by doing this, the silly things you learn by doing these things. If the TV's muted and you hit volume up, for example, it will unmute the TV, but it will not increase the volume by 1. So for what it's worth, a bit of trivia, I guess. All it does is unmute the TV. Same with volume down. It will not register that you want the volume to go down by 1. It'll just unmute the TV. And then if you want the volume down, you'd have to hit the button again. So for what it's worth, we have that feature not for the sake of the problem statement at all or for the code that we're going to write. It's strictly because that's how my TVs in my house work. And then when turning the TV back on, if the volume should be retained, so if you turn the volume up to 7, turn the TV off, turn it back on, the volume should still be 7. And if the TV was muted when it was turned off, when you turn it back on, it should still be muted. So that's our spec sheet. That's what we want to implement. These are all the features. On the other side of things, of course, I got this by just playing with TVs, and then chose 0 and 10 for the limits of the volume. But this would be talking to the customer and saying, hey, you're paying us to write software for this new TV that you're making. What are all the features you want? And this is what you and the customer agreed on. This is what the customer wants. So this is what you'll write in your software. This is your spec sheet. That's your be-all and end-all of what the feature should be, because that's what the customer agreed to. If you deliver something other than that, customer is going to be upset in most cases. If you're going to deviate that, you got to have a conversation with the customer first. So we want to go through our strategy, or my recommended strategy, of applying the state pattern. Because right now, this is pretty much your homework description, aside from, well, we're about to talk about it. But how do you approach a problem like this, applying the state pattern? Number one, I like to figure out what the API is. What are all the methods that can be called on the TV class? And then I'm going to defer to my state. By default, I'm going to defer to the state for all of the functionality of that API. Where API, it's kind of an overused term. I like to say API is anytime two pieces of code interact with each other. How they interact with each other is through an API. So if I have code over here that's going to use my TV code, however it interacts with the TV code, that's going to be the TV's API. So it's the methods that people outside of this class are going to call, outside of the TV class are going to call. So my API, what methods can be called? The next thing, we want to figure out what states we're going to have, and we want to figure out what state transitions we're going to have. That's what we want to, that's the approach that we want. So the API is very similar to the API in the calculator in the sense that we got some buttons to press. Those button presses are going to be the API. That's how the outside world, and eventually the actual human holding the remote, that's how they're going to interact with our code, is through those buttons. So let's go through this and figure out what API methods we'll have. We'll go through the spec sheet a few times today. Second pass is going to be figuring out our API. So we have, let's see, it's off, initial volume is 5, when the TV's off, volume up, volume down, and mute. So we have 3 buttons already, public. And whenever I push a button on a remote, I don't expect anything in return. We're going to have return type void here. What I expect to happen when I push one of these buttons is for the state of the TV to change in some way. But I'm not asking my remote for something in return. I don't expect my remote to spit something out at me. So it's return type void. Volume up pressed. Presser. Volume down pressed. And mute pressed. So we got 3 buttons right off the bat. Volume up, volume down, mute, do nothing. Current volume is 0. We'll still go back around to that one. Power button. The power pressed. Power button will turn the TV on and off. Volume up, volume down, pressing mute. We got those ones. TV is muted. Current volume is 0. Pressing up, down, mute. Doesn't do any, unmutes the TV. Turning the TV back on. Okay. So it looks like we have our 4 buttons. Volume up, volume down, mute, and power. We don't have too complex of a remote on this thing. Just a 4-button remote. Volume up, volume down, mute, and power. And then there's one more thing, a little bit more hidden, is especially so we can do some testing, but something so we can read the state of the TV in some way. We have multiple cases where we're checking the volume. We're saying that the volume should be a certain value at certain times, and that volume can be changing. So we need some way to access the volume. If it's in the spec sheet, the public world wants to be able to access it, so we're going to give give a method to be able to read what the current volume is. So public int current volume. And then give it some default value. Let's do return 0. So that's our API. And normally, if I'm sitting down to code this, I'll do more design work. I'll design all the architecture first before I start coding. But I'll do it kind of in parallel just for the sake of the lecture. So we can start seeing when I say something, you can see it, what I mean in the actual code as we're going through it. So I have my API that the TV is going to use. These are the methods that people are going to call on my TV and expect certain functionality, expect everything in the spec sheet to be returned by these methods or to happen on these methods. And then current volume is the only way that they're actually testing that. So when we write our tests, we won't have time to write the tests. Maybe on Friday, I'd rather do another state pattern example, do another whole example, but maybe we'll do TV testing. Maybe at least one test to make sure everybody understands how to test the calculator. But current volume is how you'll test it. So we'll create a TV, we'll call some combination of these buttons, and call current volume and assert that current volume returns the correct value. Just like on your calculator, you're going to press some combination of buttons, simulate those button presses by calling the pressed methods, and then access the display number and make sure the correct number is being displayed. So we're only testing things by calling API methods. We only have one API method that returns anything. Just like the calculator, you have one API method that returns a double. All the other ones return void. So you're going to press the buttons, and then make sure that the display number is correct. That's the only way you're testing. Okay, so let's set up our states. Let's get our structure set up. And when I'm creating my states, I like to create my states in a separate package. So I'll create a sub-package for my states. That way, in the package itself is the code that the outside world's going to interact with. And then I'm encapsulating all of my details, all of my state pattern, the things that nobody's ever going to call this code or nobody's going to care that it exists. They just care that the TV works the way it's supposed to. The fact that I'm using the state pattern is irrelevant to the end user. So I'm going to put it in a sub-package to kind of reflect that. From the other examples, you can see that Paul does not agree. Paul doesn't do the same thing. So for what it's worth, this isn't like a rule or anything. It's just a preference, and you can develop your own preferences for that one, however you'd like. I like them in a sub-package, though. New, so I'm going to create my, I'll call it TV state. I'm going to make this an interface, just like we did with the example on Monday. And I'm going to add my methods, which I'm going to cut and paste so I can avoid typos. And I'm going to add my API methods to my interface, which is going to control what methods I'm going to defer to the state for functionality. Convert these into abstract methods. And public, I could leave these keyword publics, the keyword public here. The warning I'm getting here, it'll show up, is that it's redundant. So if you have a method in an interface, recall that it has to be public. So there's no need to put the keyword public. Java's like, you don't have to tell me it's public. I know it's public because this is an interface. So we can delete these words, and those methods are still public, but we don't need the keyword. And then our warnings remaining are that none of this is used. We haven't used any of it yet. Those warnings will go away once we start using them. And in my TV class, since I'm setting up the state pattern, or else I'm going to need conditionals. I'll have to have conditionals if I don't use the state pattern here. I'm going to have an instance variable for my state. Question marks here. Which is going to be something. We don't have any actual concrete states yet, so we can't create an instance of type TV state. Nothing implements the interface yet, so we can't do anything yet. But let's set up what we're going to do is have our state And then each one of these methods is going to defer to its state for functionality. So the TV class itself isn't going to do anything. We could add some functionality here, like your calculator might have some functionality in it, but it can only have functionality that should be the same regardless of the current state. And I could also have helper methods in. Sometimes I like to put helper methods in the main class. But in general, we're just deferring to the state for all of our functionality. The TV doesn't know what it does. It just tells its state, hey, the mute button was pressed. Yo, state, what do we do when the mute button was pressed? And the state will control that. So state power pressed. And then with current volume, we still want to return whatever the state returns. So we're going to return this .state .current volume. So that's our API set up, and we're ready to apply the state pattern. We have our interface here. It happens to be the same exact methods. We're deferring to the state for all 5 methods. We're just going to say, hey, state, what do we do? Because none of these methods will do the same thing in every state, as it turns out for this example. So we have our API set up. And now the next step is going to be to ask questions. Let me pause for a second, just because I don't want too much to be going on too fast. So let's pause for a second. We got our API, and we're ready to start going through this spec sheet again and figuring out what we're going to do next. Are there any questions on how we're setting this up or what we're even doing yet? Yeah.
Is there say, universal functionality you might be able to implement?
Not really in this case. We will add a little bit more to the TV class by the time we're done, but there's not much we can. There's not much universal functionality that we can put in the TV class that's used more than once, I guess. Like we could add a method to increase the volume by 1 or decrease the volume by 1. But as it turns out, when we're all done with this, we'll only call those methods one time from one place. So we wouldn't be saving anything. But if there were multiple states in multiple places where that would happen, I would add the helper method here and then be able to reuse that code. Yeah. That's just my personal preference. I like to keep all my state stuff, I'll put all the concrete states in this directory. I just like to keep all my state pattern stuff separate from the class that's using the state pattern. I think it conveys a little more clearly that the TV is using this state pattern, and then all my state pattern is in there. It's for the Hulk example, Paul wrote the Hulk example. So, but I would do, if I were the one writing the code, I would do this. The car was not part of the state pattern, but I would put all this stuff in here. In the car, we didn't actually talk about the car pattern, but the car class, but that's what it would do. Then Bruce Banner and car, those are the 2 actual objects that the rest of the world cares about. And then the state pattern, no one else cares about it, except whoever's writing or reading the code. So I like to kind of visualize the encapsulation a little bit, where all of this is implementation detail that nobody has to care about except developers, except programmers. So if somebody else, I guess that implies a non-programmer is looking at the code still too. So I don't know. I just like it. I think it cleans things up a little bit, makes it more clear to read. But as I just mentioned, Paul does it a different way. So it's up to you to make your own choices, what way you think is better. I have no strong opinions on this one. I don't care which one you go with in the future. But for my tastes, I just like this way. Okay, so let's go through our spec sheet a second time. Let's do our second pass here. So this time, when I'm looking at the spec sheet, I want to decide what what states the TV can be in. So let's read through this with a mind of what states can we have in our code. And we're always going to have some initial state. That's the state, the state that we're in when we first create an object of this type, when we first create a TV. And then we'll have other states on top of that. But whatever the initial state is, which is, bless you, which I kind of spell it out a little too clearly maybe on this one. But the initial state is going to be off. So when we first create a TV object, it's going to be off, which sounds like a state to me. That's a state that a television can be in. It can be off. That's something that describes its current state, I guess, is off. So the TV is currently off, and then let's go through our spec sheet. Initial volume is 5. When the TV is off, we should have this functionality. The power button turns the TV on or off, so the power button is going to turn the TV on if it's off and off if it's on. Sounds like another state to me. We have an on state. Volume up is going to increase the volume, decrease the volume. Pressing mute will mute and unmute the TV. So when a TV is muted, it's going to have different functionality. So when the TV is muted, the 5 API methods are going to do different things than when it's unmuted. That's going to be another state. So muted. When turning the TV back on, the volume should return to where it was. And if it was turned off when it was muted, when it turns on, it should still be muted. So it looks like these 3 states. Maybe we'll have another one. When we get through the code, we'll have to find out. The rule of thumb is whenever you have a different set of behavior from the 5 API methods, if even one of those methods changes what it's supposed to do, you got yourself a new state. So we'll use these 3 and see if these are the only 3 we need. All right. So we have our states. We haven't done our state transitions yet. That'll be when we implement the code for these. But let's get our states here at least. So I'm going to create a new state for each one of these states. And we're going to implement the interface. Implements TV state. I like to use the shortcut to implement my methods. Gets all my code set up. And current volume is going to have the default return 0. It just adds some default stubbed out functionality for each one of my methods. The void methods can return nothing. This one returns in. So it gives me something that compiles for that method. And then let's create our other states, off and muted. And just getting whatever default functionality we get for these stubbed out methods. And now that we have our classes set up, we can create a new off. So off is our initial state. So when we first create a TV object, our state is going to be off. And we're going to import it. All right. And at this point, we're ready to go through our spec sheet again. And I'm going to do this in a fancy way like this. I have our spec sheet here, and we're going to start. I always like starting in the initial state. And we're going to go through, which this should be the easiest part of using the state pattern. We're going to go through the spec sheet and figure out what each one of these methods should do when we're in the off state. So we're not thinking about turning the TV on. We're not thinking about it being muted. We're not thinking about anything except the off state and figuring out what each method should do in the off state. And the off state, as it turns out, is the easiest one. So let's go through. We have when the TV is off. Volume up, down, and mute should do nothing. Cool, we're already done with volume up, volume down, and mute. So volume up, volume down, mute. These methods are done. They're supposed to do nothing. Current volume is 0. Current volume just happens to be the stubbed out method that I got, return 0. Cool. Current volume returns 0. Done. The power button turns the TV on and off. So when the power button is pressed, the TV will turn on. So we have a transition to on. So we're going to transition the TV to the on state. And here we have some questions of, well, how do we do that? How are we going to transition the TV to the on state? This is our first state transition that we're hitting. How are we going to do that? I'll take a breather and let you think about that. How are we going to do this? There are a few things. We saw it last time, but I just told you this is how you do everything. Now I want to see why exactly we did it that way. I'm going to get impatient today, so I'm just going to go and continue with this. So we need the TV to change its state, so we need to change the type of the object stored in the state variable. That's our ultimate goal, is to change this state, this variable. Well, it's private, so that's going to be hard to do. So let's get ourselves a setter for this. We're going to do public void state transition. I spelled this wrong in the last lecture. Transition. I just want to put an extra S in there. And this is going to take a TV state. Could be any of our three concrete states. And this dot state equals new state. So we have a method that we can call to change the state. So when we want to change the state, we're going to call state state transition, and we're going to create a new instance of the on class and transition to the on state. So that's going to get here. We're going to set the state equal to a new on, and the methods that are called that defer to the state will all defer to the on class for its functionality instead of the off class. So we'll transition to a new state and swap out all the functionality of those 5 methods through the state transition. But what else do we need to actually be able to do this? Because I got some errors here. So this state transition method, it's not static, which means I have to call it through an object. So I'm going to need a reference to an object to be able to actually call this method, and that object has to be of type TV. So I'm going to need to call this through an object of type TV, and it should be the TV that the off state is attached to. The TV that's delegating to this off state, the off state itself is going to need a reference to that TV if it's going to have any success in transitioning the state to a new state of this TV, or turning the TV on in this case. So when we create a new state, each one of these states is going to need a reference to that TV. Private TV, which I'll call TV. Public off, let me get the constructor here, which is going to take a TV. The easiest way to do it is, let me preface it like this, I always want my state to have a reference to the object to which it's attached. If I always want that to happen, I'm going to put it in the constructor as a constructor parameter. That way you can't create an object of this type, of type off, without giving it a TV to be able to work with, the TV that it's attached to. You could technically by saying null, if you're a smart ass, but we're going to avoid that. We're going to not do that and be good programmers. So TV, this dot TV equals, I shouldn't say it like that. There are cases where that might happen if this is some complex method call, and that method call happens to have some weird situation where it returns null. So that can happen, but we shouldn't do it directly. We shouldn't just type null in here. So what do we type in here? We have a reference to the TV now. We can call this .tv.state transition. This line's good. But we have errors right here because that constructor, we just added a parameter to it, and we didn't put a parameter here. So to give this state a reference to the TV to which it's attached, we need that reference to be able to pass. And this line of code is being executed when the constructor of the TV class is being called. When the constructor is being called, we have a reference to the object that's being created in the keyword this. So we pass a reference to the object that's being created, the TV that's being created. That gives the state a reference to that TV, which can actually be final. And then we can transition the state when power is pressed because we have a reference to the TV that this state is attached to. The object that's delegating to the off state for its functionality. And that's the off state. That's everything. 3 of the methods did nothing. 1 of them just did the default. And we had our first state transition. Power is pressed, we transition to the on state. Because when the TV's on, it's going to have different functionality than when it's off. To have different functionality, we've got to transition states, or else we're going to have an if off, else. We're going to have stuff like that, and we're not allowed to have conditionals. We're not going to use conditionals. So we're going to transition states to be able to change the functionality of our methods. So let's move on to the on state and do the same thing. What do we want to happen over here? Let's do some setup. We already talked about it, so let's just get this part of it done. In the on state, we're also going to want a reference to the TV. We're going to change the name of the constructor to on. And now in the off state, we're going to have an error because on needs that reference. We're calling the constructor with no parameters, but it has a parameter that's a reference to the TV that it's attached to. So we got to get that reference over there. So from TV, new off, we passed it a reference of the TV that was being created. We stored that reference in this TV variable, and then we're going to forward that reference and say, hey, new state, the state that we're transitioning to, I got this reference to a TV. This is the TV that we are controlling. Here you go, have this reference, and pass it to the next state. Now in the on state, implementing methods, we go through our spec sheet again. When we're in the on state, what do these things do? And we're going to start off with a couple actually somewhat tricky ones. Volume up button increases the volume by 1 to a maximum of 10. Some of you should be getting a little nervous how we're going to do this without a conditional. So we want to... we have a few problems here. One, we have no concept of volume right now. So we need some way to store the volume of the TV. And there's some temptation for students to put that right here. Private int volume equals 5. It's initially 5. There's some temptation to do that. Do not do that. Whenever we have some instance variable that's going to be controlling the state of, not the actual state, but controlling the values of the object, don't put those in the states. Because if I put an instance variable here, if I put an instance variable inside the state, and maybe I do volume like that, and I have the state controlling the volume, what's going to happen when I transition states? That variable's gone. It's garbage collected. And I forget what the volume is. But this volume has to persist. It has to be retained as we're switching states, as we're moving around states. So we want that volume to be part of the TV itself. So let's add this instance variable here, volume. And we know from our spec sheet that it's initially 5. And we're going to have some getters and setters that I'm going to let IntelliJ generate for me. Generate, getter, setter, volume, bam. So now what we want to do with volume pressed is access this state and modify it. We want to this.tv.setVolume, this.tv.getVolume, and bump it up by 1. That's a line that's more complicated than it needs to be just because we're in Java where our instance variables should be private. If you're in a different language where you don't have to have all your instances, you don't have to, but where your instance variables shouldn't be private, you would just access this variable directly and hit it with a ++ and be done with it. We got a little extra logic just because we're in Java. Where other languages have ways around the problem of that getters and setters are solving, which is a tangent for another day or for never. We don't really have to talk about that one. But we have a problem here. We got a max volume of 10. How are we going to handle this? So this is just going to increase the volume, and we can just blow past 10. We can have a volume of 100 if we want with this code. So we got to do something a little different, and we have to do it without saying if volume greater than 10, volume equals 10. That's the natural thing we would want to do. And we're gonna cheat just a little bit with this one. I'm going to create some proposed volume. So this is what I would like to set the volume to. Let me slide this over. Is this volume. And then what I'm actually going to set it to is something. And then let's get the whole structure set up. I'll do this in a couple of lines. I would probably do this in one line usually, but I'll do it in a few lines to really explain what I'm doing. The actual new volume, I'm going to take advantage of math.min, proposed volume, and 10. And let's name our constant so we don't have a magic number. Next volume. So if I take the min, if I increase the volume of the TV up to 11, I'm going to have the min of 11 and 10, and set the volume equal to 10 instead of 11. So it's kind of a cheap way to avoid a conditional. I'm only doing this because we have the restriction of no conditionals. But math.min will do that for us. And the reason it's cheap is math.min just uses a conditional, which I have to explicitly ban these on the homework. I forgot, Scala didn't have these ternary operators, so I'll have to explicitly mention that. I'll have to update the doc maybe. But they're obviously banned because they conditionally execute code that you write. But I'll have to update the grader so it blocks these. But this is just a conditional. It says if A less than B, return A, else return B, is what this says. So, and speaking of the grader, I forgot to, I was trying to remember this morning what it was. I'm like, there's some bug in the calculator grader, not necessarily a bug, but something I got to fix nonetheless. I couldn't think of what it was, so I didn't fix it this morning, but I'll fix it next time I'm not in lecture and I remember. Right now, if you're getting errors where it says you used a banned keyword and you haven't used a banned keyword, check your comments. If you have any banned keywords in the comments right now, my autograder will reject the submission, which I don't want it to. I'll fix that. I know how to fix it. I fixed it before, but then I must have grabbed my old code before the fix, and I don't know, I just got the wrong thing in there. But if you are seeing that and you want to keep going through the assignment, get rid of any banned keywords in your comments. Otherwise, just wait for me to upload the grader, fix the grader, and then that won't be an issue, because you should be able to use banned keywords in your comments. It's kind of ridiculous. And a TA actually found it. They took the description from the homework doc and pasted it as a comment in their code, and it contained banned keywords, and they were getting rejected every time. So if that's happening to you, that's what's up. I'll fix that. All right. I did spell. Is it one S in proposed? Yeah. All right. And then same thing for volume down. So we had two issues. We had to store the volume, and then we had to use this math trick to handle the boundaries. So let's do the same thing, but the other way around. Take the max of whatever we're changing, whatever the new volume would be, and 0. So if we went to -1, it's going to be the max of -1 and 0, and we're going to return 0 is the new volume. We're ready to move on with the assignment. Momentum picks up a little bit after that one. That's probably the trickiest part of this one. When mute is pressed, Pressing mute mutes and unmutes the TV. So this.tv.state transition to new muted of this.tv, which should give me an error because we didn't update our constructor of the muted class yet. We'll fix that later. Power turns the TV on and off. So let's grab our state transition code so we don't have to type it again. And we're going to transition to the off state. And then current volume is going to return whatever the actual volume is when the TV's on. That's the volume that the TV is currently making. So get volume is going to be what we return. So if you notice, we have a kind of tricky thing going on here. The volume that we return should be different depending on what state we're in, but the volume that the TV is at should be remembered, and we're going to remember that in this variable inside the TV class. Inside this TV object, it's going to have a variable that remembers the volume. When we're in the on state, we're going to return that value, whatever value is stored there. When we transition to the off state, we're preserving this value. This value is staying the same. It's remembering what the volume was, but we're just not accessing that variable. We're straight up returning 0 with no matter what is stored in that variable. And we're doing that without a conditional, of course. So when we're in the off state, return 0. When we're in the on state, return what the actual volume is. So that's how we're getting that functionality. It's just, once we have our state pattern set up, it's just 2 lines of code. Each one of these is just straight up return something. But if we set up our state pattern carefully, that does get fairly easy to get that functionality without using conditionals. Instead of saying, if the TV's on and not muted, then return the volume, else return 0. We have the same functionality, but a little bit cleaned up, but also more classes and more methods. So again, it's a trade-off. Let's get on with it. That's our on class. That class is done. And writing each method, aside from volume up and volume down, having a little bit of trick to it, writing each method should be pretty straightforward. Most of these are pretty straightforward, and even these ones, I forced it to be 4 lines of code, but I could write this in 1 line of code without even being too unreadable. Do we do that? That's not even that bad. Set volume to the max of the volume minus 1 and 0. All right, so let's set up our constructor for muted. Let's get our last class going on here. Muted. That should get rid of our error in on. Our on error was the constructor of the muted class because it wasn't taking a parameter yet. Now it is. And then let's go back to our spec sheet and see what should happen in the muted state. Current volume is 0. Got it? We're going to cut off access to that instance variable and just return 0 instead of returning the value of the instance variable. Mute, volume up, volume down should all do the same thing. They should unmute the TV without changing the volume. Now, mind you, it wouldn't be hard to have these actually change the volume. This wasn't done to change the assignment in any way. But that's just how the TVs that I tested with worked. If I muted and hit volume up, the volume would stay the same. It would not register the volume up. So we have a state transition. This.tv.state transition to new on this.tv. That method's done. Ugh. Oh my goodness, I can't even get the right thing highlighted. That method's done. That method's done. So mute, volume up, volume down, all do the same thing, just a state transition. And then our last one, power pressed, is going to turn the TV off. And then when the TV is turned back on, and notice that this is preserving the volume. We go to muted, return 0, we go back to on. On is still going to access the instance variable of the TV class. The volume that variable hasn't been changed at all, so we're restoring the volume when we're unmuted. And then when we turn off, when we're muted, and we turn it back on, we should still be muted. So let's go back to our off class and get that functionality. When we turn this back on, so when power is pressed, we should go back to the muted state if it was muted, and the on state if it was not muted. And just the natural way of saying that sentence, I'm using the word if, kind of gets me a little worried here. How are we going to get this method to do two different things depending on what happened throughout the TV's life cycle? Whether we got to the off state from the muted state or from the on state or from the initial state, how are we going to reflect that? How are we going to do that? Well, we can't, right? Can't do that. Without using a conditional. We could use a conditional and get it done, of course. But without using a conditional, how are we going to get that done? Well, we have a different set of behavior. Whenever even one single method does something different, you got yourself a new state. We're going to need a new state to be able to get this functionality, because one of the API methods changed what it should do. I'm going to create a new state, and I'm going to call it off muted. And this one's a little awkward because most of these methods don't do anything anyway. But when I have a state for my... Oh, we don't have a ton of time, do we? Let me not do that. We're not going to have quite time to do it that way. But off muted should do the same thing as off. I got to change the name of my constructor, muted. But instead of transitioning to on, we're going to transition to muted. And then when we're muted and we turn off, we're going to turn to off muted to get that behavior. So we had different behavior in a certain situation. We had to add a whole new state to get that behavior in there.